In this example, we have combined both example 2 and example 3. That is, this language contains two strings A, A. It means if I have a single A, then the finite state must accept that string, and if I have AA, then also the finite state must accept the string. The finite state obtained for this language is, so for a single A, initial state Q0 for one compulsory A input reaching to Q1. As A must be accepted, Q1 will be the final state. And along with A, even AA also must be accepted. So from Q0, for 1A it has reached Q1. Again from Q1, for one more compulsory A, it reaches Q2, which is the final state. So hence both the strings A reaches the final state, A reaches the final state. You can see here we have discussed every finite state has one single start state and it can have one or more number of final states. This is an example wherein you have more than one final states. Example 5, summation A, and the language contains 0 or more number of A's. 0 or more number of A's means L containing 0 A's, 1 A's, 2 A's, 3 A's, 4 A's and so on. 0 A's, it means epsilon, 1A, 2A, 3A and so on. If we represent this language, the language can also be stated as A raised to n, where n is greater than or equal to 0. If n is equal to 0, epsilon. If n is equal to 1, 1a. If n is equal to 2, 2a's and so on. The finite state obtained for this language is, as we have already seen in example 1, how do you represent epsilon? Epsilon is represented as initial state Q0 itself as final state representing epsilon. Now, if I want one single A, then I'll take a self loop to the same state Q0. Start state Q0, taking one self loop for one single A reaches Q0, which is the final state, hence the string is accepted. Similarly for 3 A's, start from Q0 initial state, 1A, 2A, 3A reaches state Q0, which is a final state, hence the string is accepted by this particular finite state machine. Let us take next example. A language consisting of even number of A's, that is 0A's, 2A's, 4A's and so on. The language can also be represented as A raised to 2n, where n is greater than or equal to 0. Since the first string is epsilon, as you know, just now we have discussed, initial state will be the final state. This FSM will accept the epsilon string. Next, coming to string AA. If we come across 1A, then it must not be accepted. But if we come across 2 A's, then the string must be accepted. So how do we design this? So initial state is a final state. We have one compulsory transition for input A going to state Q1. Then the string must not be accepted. So the state Q1 is an intermediate state. But as you know, the second A must be accepted. So at that time what to do is take one more transition from Q1 for input symbol A back to Q0, which is a final state. Now if you see, string AA start from the initial state Q0, 1A going to Q1 and second A going to Q0, which is the final state. Hence the string AA is accepted. Similarly, let us take one more string, 4A's. Start with initial state Q0. First A from Q0 it is going to Q1. Second A it is going to Q0. Third A to Q1 and fourth A back to Q0. And here Q0 is the final state as the string is accepted. The logic here is when you have one odd number of A's, then you will be in the intermediate states. When you come across even number of A's, you will be in the final state. So this is the finite state machine for the language consisting of even number of A's.